Hey gang, so this is the check for understanding number 3 that I sent you home with today. So let me see if I can help you with through some of this. Okay, so for this function, find the intervals where f of x is greater than 0, but f prime of x is less than 0. Only way to do this is we're going to have to graph it. So I'm going to come over here and I'm going to graph it. So I'm going to hunt down my calculator that I have sat down somewhere. And I'm going to put both of these into my calculator. So first thing I'm going to do is go to y equals, and I'm going to put this in. So x to the 4th power plus 3x to the 3rd minus 36x squared minus 68x. Oh, plus 240. Okay, let's see if we can graph this. Okay, so it's up, down. So it's definitely got like a whole lot going on. So let me see if I can zoom out a little bit and get a little better picture. Not really. Let me zoom a little bit further out. Okay, so it's going down, then up, then down, then up. So it looks like it's looking something like this. It's coming down, then up, then down, and it's coming back up. Okay, so it's looking something like this. Okay, that's what it's looking like. And again, it doesn't have to be perfect. It just gotta look something like that. So now, this is the interval. So I can see here, 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 and here. I probably need to label these points so that I know what these points are. So let's find the zeros. Okay, I've got a 0 at -4, at 2, at 5, and let's see, was there another one? Okay, here we go. -6. Okay, so we've got one at -6, -4, and then 2, and then the other one was at 5. Okay, so I got 4 turning points, which makes sense because it's to the 4th power. Okay, so I've got lots of intervals in here. So now I'm going to change my colors. I'm going to go to blue. I'm going to take the derivative. So I'm going to do f prime of x equals 4x to the 3rd plus 9x squared minus, let me do 36 times 2, I don't want to mess that up, 72x minus 68. Alright, so I'm going to put that derivative in there. Oh yeah, I was looking at my paper to make sure I didn't do my derivative wrong. Okay, now one other thing I want to do, so here's my derivative, and so I'm going to graph, I'm going to go y equals 4x to the 3rd plus 9x squared, oops, minus 72x minus 68. Okay, I definitely can't see that very well, so I'm going to zoom number 9. Let's see if we can, oh, probably not. So I'm going to zoom in. Let's zoom 6. Okay, that is definitely a little difficult to see, isn't it? So what if we zoom, what does 0 do? Zoom 0. Kind of hard to see still, isn't it? I'm going to zoom in a little bit. Yeah, I still can't really see it. So let me just do my windows. Let's look at this. So on the derivative, I need to go out on the y value. It looks like I need to go out about 1,000. to 200. I'm just looking at the y's to the x. So let's see, the x values, I need to go out to about a positive 10. But the y values, yeah, I need to go out pretty far. Let's see what that looks like. Yeah, I can see it a little better, but I need to go the other way a little bit more. So let's go to zoom. Let's go out negative 10. Let's see if that's enough. Yeah, that's a little easier to see. Okay, I'm going to do this. I'm going to do y, and I'm going to go up here. I'm going to hit enter, and I'm going to graph it. Did you notice how when I hovered over that, now I can just see this one. So let me do that one more time. If I go over the equal sign right there and hit enter, it turns that black off, and that makes it so that I don't see that graph when I graph it. So now this point right here, 1, 2, 3, 4, 5. It looks like that 0 right there was at negative 5. Well, I can't tell exactly. So here's what I'm going to do. I'm going to go second. Actually, I'm going to go to my graph. I'm going to calculate. I need to calculate those zeros. Let's come over here. Let's figure out what that 0 is right there. Oh, yeah, that's a weird 0. Negative 5.11. Okay, so there is negative 5.11. Okay, and then let's calculate another 0. Let's come over here. Go on the other side of it. Negative 0.88. So the next one is going to be about right here. It's negative 0.88. So we're going up. We're coming down. And then we're going to calculate. On the other side of that one. And that is 3.75. So right about here, 3.75. So we come down and we come back up. And then this one just goes up. Okay. Now, let's remember the rules of the derivative. When the derivative is above the x-axis, it's positive. When the derivative is below the x-axis, the graph is negative, right? So that's our rule of the derivative. Now, when we look at this, here's what it wants to know. It wants to know on the interval, when is f of x greater than 0, but when is f prime of x less than 0. F prime of x is less than 0 only in the yellow. So we can't look at any of the f primes when they're above. So we can only look at when they're below. I'll use my red pen to kind of highlight this. So we have to look anywhere in between here, here. We can focus on that in there. And so what I'm going to do is I'm going to kind of shade this in here. This shaded spot is when f prime of x is less than 0. Those are the only ones where f prime is less than 0. So I'm going to look on there and I need to figure out when is f of x greater than 0. So in this interval here, f prime of x is less than 0. Is f of x greater than 0? Yes, but only, not the whole interval, is it? Not during that whole interval. What if I could do it in green? Only from 6 right here and up. Only from negative 6 and up. From negative 6 and down, that's when it meets that criteria. So from negative infinity to positive 6, we definitely meet that criteria of f of x being bigger than 0. Yes, we are bigger than 0. And f prime of x being less than 0. Yes, but once we pass that over, after 6, f of x becomes less than 0, right? So we only go all the way to there. So now we want to look again, and let's see. Right here at -4, we're less than 0 here, all the way to 2. And f of x, which is this one right here, from 4 all the way to 2. Look, f of x is positive right here, right? So right here, f of x is positive, and f prime of x is negative right here, but only from -4 to 2. We meet that criteria, I would say that. And then, is there anywhere else? Well, here, f of x is greater. Where is my graph, though? F of x is greater than 0. F prime of x. No, f prime of x at 5 and up, f prime of x is nope. So yeah, I'm thinking, I have a note here that 5 to positive infinity fits that, but f prime of x is not less than 0 during that interval. Yeah, I'm just going to say during these right here. So f of x is great, because right here it slips down, and f of x doesn't get bigger until right here. But here, f prime of x, let me follow my f prime of x. No, my f prime of x is bigger. So yeah, so I'm just going to say those two. That's a really tough one because the intervals are kind of wonky. I would say if you understand how to label this part and you understand your turning points, you're good. That's the main thing on that. Don't worry about that weird interval stuff. Okay, find the number of stationary points for the graph of this. So let's see if we can just graph it. So we're going to go here. Remember, to find the stationary points, the easiest way, because sometimes when you graph it, you can't see them. And I bet on this one, because typically that's what I do when I pick these. I pick the ones that are hard to see so that you can't just graph it. Oh. Oh my gosh, I keep hitting buttons. X, there we go. I pick the ones that are harder to see, so that way you have to know how to use your calculator. Okay, so let's graph it. Okay, so I kind of wonder what's going on right there. I'm going to zoom 6 right there. Oh, I can't see anything. Well, it looks like it's just doing that right there, but again, I'm not sure. I mean, what if it's doing some weird thing down here and I just can't see it? I'm just not sure. Just not sure. So, I could do this. I could go here. Now, one way I could do this is I could do my derivative, find the zeros. Now, I'm going to remind you how to do this on your calculator. I want to remind you too, when we graph it, we can also go to the table. We can look, this goes up to 29,000, and then it's going down to just going from there. So we could do it this way. We can go to our window. We're going to go to 17. Let's not go that big. Let's go to about 8. So let's go to 50,000. So let's go, -10 to 10 is good. But let's go on the Y, let's go to, I think it was 17,000. Oh. And then let's go to 50,000. I think that was enough. We need to go lower. Okay, let's go. Let's go lower on the X. Let's go down, nope, on the Y. Y minimum, let's go to -10. Nope, we need to go lower still. On the y minimum, let's go to negative, and let's scale it. Let's go by like 50. Getting a little bit better. Let's scale it by 100. Just keep playing with it. I'm going to do 250. Oh, it's getting a little bit better. You just kind of keep playing with it. Scale it by 500. Again, you still can't really tell what's going on there, can you? It's like, I don't know what's going on. It kind of looks good, but I'm just not sure. Still not sure. So you're kind of like, oh my gosh, and you kind of get exhausted sitting here trying to make it and figure out what in the world is going on. So then you're like, okay, I just can't do anymore. I don't know what's going on. So what if we just took the derivative? Because that would sure make it easier. So 4 times 12. So let's do that. Let's do 48x to the third minus 6x squared. Oh, sorry, minus 6. Oh, I'm sorry, minus 8x. And then the 11 goes away. That's an 8. That does not look like an 8, but that's an 8. Okay, y equals, and now, that's my derivative, but I want to show you on here how to do that. Remember we did it in class. Hit math, go down to number 8, which is the derivative. You put dy dx. To get this equation right here, you do alpha y equals y bars, and you put in y1. And you want the derivative with respect to x. Okay. Now, I'm going to go back up here. I'm going to turn this graphing off by hitting enter. And I just want to graph the derivative. So it's going to graph it. I see it up here spinning. And there's the graph. Now, it definitely looks kind of weird. So I'm going to zoom to number 6. See if I can get it to graph it a little bit better this time. Okay, there it is. So there's the graph of the derivative. It goes up, it comes down, and it goes up. It is much easier for me to see the turning points. Once I can see the turning points, 1, 2, 3, not the turning points, the zeros, I know how many turning points it has. I can see that it crosses the graph 3 times. How many intercepts are there? 3. That means there are 3 stationary points. Now, stationary points. Can't spell. If I asked you what are the stationary points, could you tell me? Yes, you could tell me the turning points if I wanted to know it. The easiest way would be to zoom in. And see if we could see them. That's probably the easiest way. It looks like they're kind of in weird spots, so we could calculate them. Actually, the easiest way would be to do a polynomial app solver. I think I'm going to do that because that's going to be way faster. I'm going to do number 9. This is degree 3. I'm going to go over to degree 3. I'm going to do next, and I'm going to solve it. It's going to be 48, negative 6, negative 8, and 0. And there it is. That's way easier than trying to calculate all those. So if I wanted to know them all, I could say the turning points are at x equals negative 0.351, 3 sig figs. The other one is at 0.476, and the last one is at 0. Those are my 3 turning points. Those are my zeros. Those are my turning points from a graph. It said find the number. It did not say find what they are. So we're really just looking for 3, but if you wanted to know what they were, we could tell you. Okay, the graph of the gradient. Remember, gradient is just a fancy word for slope. when you're working with derivatives, it's the derivative. The graph of the slope function of the function f of x is shown. So this is the derivative. For what values of x is the function of f of x increasing? If it's increasing, it would be a positive derivative. Well, pink is my positive. You know what? Isn't this one always above? It's always above. That's always above the x-axis. Is there any values that's below down here? No. If there's no values that it's below, then that means for everything. I might as well just say, you know what? The derivative is always increasing because the derivative is always positive. So I'm going to say for all values of x, since what? Since f prime of x is always, what is f prime of x always? It's always pink. It's always positive. Since this is always positive, the function's always increasing. Which would mean if I were to graph a possible representative of this function, it would always be going up. Whatever f of x is, it's always going up. It never comes down. The tangent line is always positive, as it always has a positive slope. Okay, last one down here on this one. Given a function f of x equals x minus 1 over x, find x, an element of the real numbers, for which f prime of x equals x plus 1. All right, so given this function that f of x equals x minus 1 over x, let's find the derivative. Let's find f prime of x. Well, let's rewrite this one real quick. X minus 1x to the negative 1. Let's take the derivative of this. The derivative of x would be 1. 1 times negative 1 would be 1. This would be x minus 2. Right? So, given this function, find x an element of the real numbers for which f prime of x equals x plus 1. Here's what I know that f prime of x equals. The derivative of this is this. But they're telling me how does f prime of x equal this? So you basically want to take f prime of x and you want to set those equal to each other and say, when does f prime of x equal that? And it has to be a real solution. In other words, you can't get an I in there. It can't be an imaginary number. So here we go. Let's say x plus 1 equals 1 plus, and I'm going to go ahead and say 1 over x to the second power. I'm just going to make this without a negative exponent. I need to solve this. Okay. So let's see. Well, would you agree if you have 1 on each side that actually those would cancel out? And I get x equals 1 over x squared. I would put this over 1 and I would cross multiply, so that would give me x to the third equals 1. I would take the cube root of each side, and that would give me x equals 1. So, given this function, find x an element of the real numbers, that's an element of the real numbers, for which x prime of x equals x plus 1. Well, I guess x would be 1. That's my answer. X would have to be 1 in order for this to work out. All right, guys, and that is check for understanding number 3.